Advanced Math, Set 89, The Ellipse, Part 2. Okay, so just a review of an ellipse. If you have a horizontal ellipse, it's longer than it is tall, and A is the distance from the center out to the right or left side. So the coordinates of each side are A0 and negative A0. The distance from the center up to the y-axis, or up to the ellipse on the y-axis, is b units long. So our coordinates on the edges are 0b and 0, negative b. And then we have two foci, F1 and F2. Now, something with ellipses. A is always bigger than b, and that's what you kind of use as your benchmark. So for this particular ellipse, x squared over a squared equals y squared over b squared equals 1. If you have a horizontal ellipse, it's x squared over a squared. If you have a vertical ellipse, it's going to be y squared over a squared. So it's kind of like it's circling the axis that it's focusing on. So if it's wider, it's circling the x-axis. If it's taller, it's circling the y-axis. Okay, so we'll look at a horizontal ellipse. So we have the same thing. The distance from the center to the y-axis on the ellipse is is a. So our coordinates are 0, negative a, and 0a. The distance on the x-axis, the horizontal distance, is b. So our coordinates are b0 and negative b0. And then we have our two foci. And for this equation, it's going to be x squared over b squared plus y squared over a squared equals 1. Okay, so when we are talking about ellipses are drawn by, if you have an imaginary piece of string that you tie to both foci, and you pull the string taut, and then you draw, what you're going to draw is going to be an ellipse. So if I take the pencil and I move it over a little bit, then the distance 1 and distance 2 changes, but the length of the string does not change. I still have the same length of string. So distance 1 plus distance 2 is still the same distance. It's just what changes is the length of the distance 1 and distance 2. Okay, and then if I pull that all the way over to the horizontal side, you can see that I've got a piece of string here that is horizontal, and there's actually an overlap in this section. So there's actually two pieces of string right there that are overlapping each other. So if we take that piece and just kind of draw a little imaginary line over to the other side, that's that distance there. So that section M, which is doubled, we just have put it over on the other side. So if you remember, the horizontal distance here is going to be A, so the distance of the entire thing is 2A. So the length of the string is 2A. So in other words, distance 1 plus distance 2 has to always equal 2A. Okay, so if we take this string and we have it cross exactly over the y-axis, then we know that one side of the string is A and the other side of the string is A because it's exactly in the middle. Well, now we've formed a right triangle using the x and y axis. So using A, B, and C, we can use the Pythagorean theorem. So here's an example. Write the standard form of the equation of the ellipse with vertices at negative and positive 5, 0, and the foci at negative and positive 4, 0. So the first thing we'll do is we'll draw a picture of what we're talking about. The vertices are at positive and negative 5, and so we can draw those in, and then we know our foci are at 4 and -4. Now, in order to find the equation, we need to figure out what A and B are. A is pretty easy because we can see that it's 5, but B is what we're going to have to figure out. We need to figure out the height of this ellipse. So in order to do that, what we can do is draw a right triangle, and we know that the distance to the focus is 4, and the distance of that red part, the red string, is going to be 5 because it's the same as A. So now we just need to use the Pythagorean theorem to figure out what B is. So B squared plus 4 squared is equal to 5 squared. B squared is 25 minus 16. B squared is 9, so B is 3. So we know the height is 3. Now we can begin to write our equation. We know that x squared over a squared plus y squared over b squared equals 1. That's the standard form. And now we just need to plug in a and b. We know that a is 5, so 5 squared is 25. We know b is 3, so 3 squared is 9. And there's our final equation. Let's do another example. Write the standard form of the equation of the ellipse with vertices at 0, positive and negative 6, and foci at 0, positive and negative 5. So this example, we can tell it's going to be a vertical ellipse. So we'll start by drawing it and then filling in what we know. We know the vertices are 0, positive and negative 6, and then we'll put the foci in there. So in this one, what we need to figure out is A. We know that B is the length of string, which is also equal to the length from the center out to the vertex. And we know that the distance to the focus is 5, so we need to figure out B here. So B squared plus 5 squared equals 6 squared. So B squared is 36 minus 25. So B is the square root of 11. Now we can write our equation, and because it's a vertical ellipse, it's going to be x squared over b squared plus y squared over a squared equals 1. So we have x squared over 11 plus y squared over 36 equals 1. Okay, so a horizontal ellipse has a major axis of length 10 and a minor axis of length 4. If its center is at the origin, find the coordinates of the foci and write the equation in standard form, then graph the ellipse. Well, okay, so our first clue is it's a horizontal ellipse. So we've got that much. We can start to draw our ellipse. So it's horizontal, and we know the major axis is 10 and the minor axis is 4. So that whole distance is 10. So that means that the vertices are 5, 0, and negative 5, 0. We know the vertical distance is 4, so we've got 2 above and 2 below. Now what we need to do is we need to figure out what the foci are. So in order to do that, we'll draw our triangle, and we know the distance of the bottom is A because we don't know how far it is to the foci. The other distance is 2, and we know that hypotenuse of that triangle is going to be 5 because it's the same distance as that horizontal distance. So using the Pythagorean theorem, a squared plus 2 squared equals 5 squared. So it's 25 minus 4, so a squared equals 21, so a is the square root of 21. So now we know what our foci are. Our foci are square root of 21, 0, and negative square root of 21, 0. Now we need to write our equation. Our equation is going to be x squared over a squared plus y squared over b squared equals 1 because it's horizontal. We know a is 5, and we know b is 2. So there's our equation, and then we already have a graph drawn.